Let's say we have a situation where we're looking at our network commands and we're not sure which interfaces on the router are in fact running the protocol. Well, what we can do is this. We can do show IP EIGRP interfaces. If an interface lists here under the output, we are running the routing protocol EIGRP for that interface. That's really important because sometimes our network commands are hard to read. If we get creative with the wildcard mask, we may not in fact know which interfaces are running the protocol. Now, you can certainly interpret it from the proper reading of the wildcard mask, but this is the way to be really confident. We can also see our peers, and then the rest of this output is not really of interest to us. Something that is absolutely crucial for EIGRP operation and troubleshooting and manipulation is the topology table. The topology table represents the good, the bad, the best routes that EIGRP is presently aware of. Here's how to read it. We look at the autonomous system number, sometimes called process ID. So this router is running autonomous system 110. Its router ID is the following. There are some codes, and we're generally going to see P or A. P indicates that it's a stable route, and A indicates that we are converging. So we don't want to see A's, especially A's that are there for a long time. We might also see some statuses which go to the communication, the packets of EIGRP. These are some of the 3 key packet types for EIGRP. Let's make sure we can read each of these lines. We must be able to do that. I can't stress that enough. We must be able to read these. So a successor, as we can see here for the 96/27 network, a successor is the best route to that network. The best. Feasible distance, FD, is the metric. And we can see which routes are directly connected. Which routes are directly connected to this router? I see 2. I would want to be able to interpret which networks are directly connected. I can also see that I have created a summary, a route summary. We have a route summary right here. That route summary, and in fact, I'm going to change that just a little bit. That's the route summary for 192.168.1, and we have a second route summary for 172.16. Now you see something interesting. It says null 0. Don't be upset or perturbed by that. When we route to null 0, we are throwing packets away. That is the garbage can. We call that the bit bucket. But we get this operation anytime we have a summary route on the router. And it allows us to be confident that we're not injecting a loop in the topology caused by genericizing the route, by summarizing the route. I can also see a very important entry in this table. That's the follow, the very last one. This is the most representative of a network in our topology table. Why do we see that? Or why would I say that? Because this is not a summary, and it's not a directly connected network. It's one of the routes we've learned from our neighbors. And so we can see some key parts of it. We still have successor and feasible distance, but I want you to read this information in the parenthetical. We still see the feasible distance, but then we have the reported distance. That is the metric that our neighbor has to reach that. Now, this is an input to the dual algorithm. And so it's really important that we be able to say, all right, I know that's the feasible distance, the 40 million value, and the 28,000 value, that's the reported distance, sometimes called advertised distance. And we're going to use that for qualification of things like feasible successors, which are the backup routes EIGRP uses.